Okay, so this is our lecture on gas laws. So if you haven't already, you need to go open up your Cornell Notes template that is on Google Classroom. So you will go to the classwork, and we are now in Unit 4, so you can click Unit 4. You will scroll down till you find gas law notes here. And here is your Cornell Notes template to go ahead and do your notes. All right, so let's go ahead and get started. All right, so gas laws. So we should be able to identify and use the different gas laws by the time we're done with this week. And we'll practice a couple more. We'll do some FETs and some other practice to go ahead and get you guys better at using them. Our essential question for these notes are, how do you use and identify the 3 gas laws? So there are 4, but we're going to leave that one for AP chemistry, but we'll deal with just the basic 3 gas laws. Okay, I want to do a couple of definitions and reminders. I know you guys have gone over diffusion, if you remember it from biology, but it is the spreading of a gas through a room, so from the front to the back. So, and it's caused by the collisions with other molecules, slow down diffusion. So basically what happens is the molecules hit each other and they slow down. It's almost like bumper cars, right? So if a bumper car hits another car, then it kind of slows down unless you give it more energy, okay? And we'll learn how to give them more energy as we go through this unit. So this is kind of what happens. So this is diffusion, and you played with it a little bit on your gas properties FET, but you'll have a partition, and then you noticed if you removed it, then it kind of spread out evenly to the rest of the room. Effusion, and this is not on the test, but is to give you a background, is like just making a hole in the divider, and it just spits out. They still move across, just like on a cell membrane in biology, okay? All right, Kelvin, that is the temperature measurement that we learned in the first unit that we use here in chemistry. So it is called the absolute temperature scale. We call it kelvins. And it's a measure of the average energy of motion, which we learned in our KMT notes, our kinetic energy for a gas molecule. Kelvin scale, big thing is, does not contain any negative numbers. And what we learned a little bit, you played with that, the gas properties, is absolute 0 Kelvin, as no movement of molecules. And we also saw that this never really happens. It's in theory, but no movement of molecules never really happens, not even in a solid. All right, measuring gas. What do we do? Well, all temperatures used in gas equations need to be converted to Kelvin. So if you ever have a gas equation, and we'll practice a little bit, we're going to focus more on the relationships here, but Kelvin equals Celsius plus 273, or Celsius equals Kelvin minus 273. These equations are actually on your equation sheet. I will never ask you to figure those out. So we can do a little practice. So I want you to do a little practice. Convert 27 Kelvin or Celsius to Kelvin, and then convert 473 Kelvin to Celsius, okay? So take a moment and do that. Okay, so hopefully you work this out. You should have got 27 degrees Celsius actually equals, and it came out 300 Kelvin. So it's 273 plus 27, and then 400 Kelvin to Celsius is actually 200 Kelvin. So it's 473 minus 273. All right, so that's just a little practice. We'll do it a few times more, okay? When we measure gases, we're going to focus on 3 of them here. There's actually 4, but we're going to really stick with just 3. It's called P for pressure, V for volume, and T for temperature. So these are the measurements that we do for gases. So pressure is P, and these are the units that you'll see in pressure. So when you're looking, and I'll show you when we do our practice problem, when you're looking at a practice problem or a word problem, this is how you would identify a pressure. So it can either be in atmospheres, and 1 atmosphere equals 760 millimeters mercury, which equals 760 torr, which equals 14.7, what we call PSI, and which equals 101.3 kilopascals. So these are just kind of units to help you identify them, what would be a pressure measurement in a word problem. Then we have temperature, and of course temperature is in kelvins, is T, okay? Then we have volume, which is V, and this is basically volume is the measure of the amount of space that something occupies. If you remember when we talked about mass in the beginning, mass is about how much stuff is inside something. Volume is about how much space it takes up. So it occupies in the world. So there is, molar is a volume that 1 mole of gas, and I know you guys don't know moles. We'll figure it out next semester. 1 mole occupies 22.4 liters. So it's just kind of, if you know what a mole is, that's great. Everything that we will calculate here in regular chemistry will be at what we call STP, which is standard temperature and pressure, which means it's 0 Celsius or 273 Kelvin and 1 atmosphere. So unless I give you a different pressure or a different temperature, it will always be at what we call STP. Okay, so whenever I say STP, I just mean standard temperature and pressure, which is 0 Celsius or 273 Kelvin and 1 atmosphere. All right, so what is the relationship? Well, the first one is what we call Boyle's Law, and I know it says N up here. I want you to ignore that. Don't worry about that. Boyle's Law, which gives us the equation pressure 1 times volume 1 equals pressure 2 times volume 2. Okay, and so this is the relationship between pressure and volume, and we'll see a couple mathematically how this works up. And because temperature is not in here, it's because temperature is held constant. It's not a factor. So basically what this tells us is that they are inversely proportional. When we play with the equations, you'll see how that works, and you'll also see it in some of the demos. So as pressure increases, volume decreases to keep it the same. And as pressure decreases, volume increases. So they are inversely proportional. So they are opposites, if you remember. So if one goes up, the other goes down, okay? And that's Boyle's Law. Our next law will be called Luzak's Law, which is pressure and temperature. And so it gives us a relationship between pressure and temperature. Then volume is constant. So volume is not a factor. So if volume is held constant, you will use Luzak's Law. And it's pressure 1 divided by temperature 1 equals pressure 2 divided by temperature 2. And the big thing is that temperatures always must be in Kelvin. And that's because if you remember, when we talk about gases, we're dealing with the movement and their kinetic energy. And so we need to make sure it's in Kelvin because that's how we measure that. And this one, as temperature increases, the pressure increases, which means these are what we call directly proportional. So these are our twins. Again, just like when we did the wavelengths, we have 2 laws that are the same, and one is the odd guy out, which is Charles' Law. So Luzak's Law has a directly proportional, so when one goes up, the other goes up. And we'll play with these a little bit mathematically. Okay. Our last one is called Charles' Law, and it deals with volume and temperature. And it's volume 1 divided by temperature 1 equals volume 2 divided by temperature 2. And pressure is constant. Notice pressure isn't in here. So whenever pressure is not a factor, whenever it's held constant, you will use Charles' Law. Okay. And you're going to see some of this work in the PhET as well. And again, temperature must be in Kelvin because we're dealing with gases, and so we deal with kinetic energy. And then as temperature increases, the volume increases. And we'll play with a couple of these. You're going to play with the PhET as you see that happens. And then you'll also do some calculations with me. And so again, Charles' Law is a directly proportional. Notice the directly proportional ones are divided. And I'll show you how to rearrange these to make these a little bit easier to use. But this is pretty much that when temperature goes up, volume goes up. Okay, that's the big relationship there. All right. So now I want you to go back through your notes, and you're going to go back and highlight any concepts that you feel are important. Make any connections with the notes, add questions you may have to the left column, and then at the end, write a 3 to 5 sentence summary of your notes. All right, so that will end our notes, and I'll see you next time.